Okay, today we are going to continue talking about conic sections. Conic section we're going to talk about today is called an ellipse. Ellipse is a set of points in the plane where the sum of the distances from two fixed points, called foci, is a constant. It looks like a squashed oblong circle. So our red shape on the outside here is our ellipse, and what we're saying is there's two spots in the inside of this shape where if we take the distance from any point on the edge and we find straight line distance to those from those foci points to the point on the edge of the circle, we add those two distances together, it will be the same for every other point we pick on the edge of the circle, meaning from here those two distances are equal. If I'd added those and measured those and found the sum of those two distances, it would equal the sum of all these other distances, and that happens all the way around this shape. We stick this in the coordinate plane, it looks something like this, and those 2 points then garner some coordinates, and we're going to call them C and negative C. We'll see that when we get to the equation on the other side. Okay, but it's a squashed circle. Now, being that it's a squashed circle means that one axis of this is going to be longer than the other. Longer axis is called the major axis. So if we look at this picture right here, the major axis on this one, longer axis, is going to be in the x direction. So it's said to have a x as its major axis. If it was longer on the y would be the major axis. So let's jump in and look at the equation. So this here is our equation of an ellipse. Now, this is not the standard form. We'll get to standard form tomorrow. But this is the form that we want to get it into to make it easy to find the points for this. So if we look at this, we have two fractions added together, x squared, y squared in the top. We get value a squared below this x squared, b squared below the y squared, always equal to 1. That's an important factor right here, important thing to remember. These things will always be set up equal to 1. Now, these are going to be numbers down here when we look at this as an equation, and these numbers have a relationship here. First off, they're both bigger than 0. Second, a is at least equal to, but should be bigger than b. So a is bigger than b. So what this is telling me right here is that x squared has the bigger number as its denominator. Y squared has the smaller number as its denominator. If they're equal, it'll actually make a circle, and we'll talk about that later on. But right now we're saying a squared is going to be bigger than b squared, so therefore the bigger number will be below the x squared. What that means and what that gives us is it gives us an ellipse that has a major axis on the x, which means the focus and vertice points are on the x-axis, meaning that the numbers that we find from these things are going to be they're going to be the x values in this. Y values are going to start at 0. Okay, so focal points come from the a. Now do remember this is a squared in the formula, not a, so I'll have to take square root to figure out these numbers here. Focal points come from this value of c, which we haven't figured out how to find yet, and then this b squared tells me the minor intercepts of this thing. These are going to be y's for this one because the minor axis is the y. Okay? Now when we go through, we go to set this up. This value of c is found using the Pythagorean theorem. In the blue here, you can see this right triangle drawn in here. If we set this up, this would be b squared plus c squared equals a squared, but we want to solve for c. We're going to leave this actually as in terms of c squared, because we subtracted the b squared to the other side, we would find out that c squared is equal to a squared minus b squared. Obviously, we could then take the square root and be able to find the values of c. Now, the only thing that changes for this, when we want one that opens up and has a major axis on the y, is we get a slight change in the equation. Only difference in this top setup, notice that x squared now has a b underneath it, meaning that the x squared has the smaller number, the y squared now has the bigger number as its denominator. When that happens, we get an ellipse that is longer on the y-axis, has a major axis on the y. Vertices are now on the y, meaning that that's 0a for our vertices. Foci points are going to be on the y-axis as well. That'll give us 0c. We find c the same way we did before. X-axis now becomes the minor axis, and we find the intersection there with the b values. Now, we're mainly going to be worried about identifying the features, creating a real basic sketch, but our overall goal with this, not necessarily our overall goal, our overall method to start with this, determine which axis is the major axis. That'll determine which way the points need to be listed with A and C, whether they're going to be X values or they're going to be Y values. Vertices are always where the graph crosses the major axis. That's how we determine that. Then we'll graph the function. And that's just kind of a general summary. So let's go ahead and look at one and see if we can figure this out. So I want to find the focus, vertices, and minor intercepts, and identify which axis is the major. So when we go through and we do this, let's see. So we're in the right form here. We've got x squared over something, y squared over something. Two numbers here. We got a plus in between them. That's also important. They should be positive. And it's already equal to 1. That's what we want. So that means these numbers down here are going to be A and B. Now, let's see if we can determine which axis is going to be the major axis before we do anything. So which one of these numbers is bigger? 9 is bigger. So that means that this is our A squared. 5 is smaller. This is going to be our B squared. So since x squared has the larger denominator, that means the major axis is going to be the x-axis. So that means that we have one that looks like this. Pardon the crudity of that drawing. And what's important about that is our vertices, the numbers we find from A, are going to be here, and those A's are going to be x values for this thing. The C's for the foci points are going to be x values as well. And that means our minor intercepts, these things up here, this is going to be from the B, and they're going to be y's. So it's telling me where all these numbers are going to go when I go and I find this. So let's list this out. So A squared is equal to 9. So therefore, 3 dots, A equals, sorry, having some technical issues, A equals 3. If B squared equals 5, so therefore B, now there's no perfect square root of 5, so we're going to leave it just like that, the square root of 5. Now we're going to use these two values to find the value of C, but C squared equals A squared minus B squared, so that's 9 minus 5, because we just take those numbers straight from the bottom. 9 minus 5 is 4. So therefore, C is equal to 2. So now we have all the information to list these points and create this sketch. So let's list our vertices first. Vertices are the major axis intercepts. Those come from A. So we're going to have plus or minus 3, 0. And I'm actually listing 2 points with this. 3, 0. And negative 3, 0. And I don't care which way you list this. I like to do it this way sometimes because it saves a little bit of writing. Okay, foci. That comes from the C, and those are going to be x values. So C was 2. So this was plus or minus 2, 0. And again, that's 2, 0, and negative 2, 0. And last one is going to be our minor intercepts. Minor intercepts come from our B value. That's going to be 0 plus or minus the square root of 5. And because I want to create, I'm going to show you a little sketch here. Let's actually plug this in and see what is the square root of 5. Square root of 5 is about 2.34. So this right here is about equal to plus or minus 2.24. Because what that means is I can now put points on all that and actually have it drawn out a little bit better. This is what that shape will look like. It is slightly longer on the x than it is on the y. It's actually pretty much closer to a circle than what this really looks like, or what we thought it would look like normally, the way I drawn it up here. Okay, but we would label everything. So we'd see here's our negative 3, 0, our 3, 0, This is our 2, 0, our negative 2, 0, so on and so forth. And then our minor intercepts up here is 0, root 5, and 0, negative root 5. So identifying key features, that's where we start. So let's try again. Same thing, I want to figure out all the important information for this one so I could make a sketch. Now, what's different about this one than the first one we did? This doesn't have fractions in it. And one thing we always need to remember is this number out here, this must be 1. So the way that we make this 1 is we're going to divide everything by 16. So we're going to get x squared over 4 plus y squared over 16 equals 1. So here, there's our two numbers for a squared and b squared. That's going to be our b squared, that's going to be our a squared. This is our a squared this time because this one is bigger. Now what that means is that our major axis is a y-axis. So our vertices and our focus are going to be on the y-axis this time. So the major axis here is the y-axis because the bigger number is underneath the y squared and the fraction. So let's go through and find everything. So if a squared is 16, so that means that a is 4. If b squared is 4, that means that b is 2. So c squared is going to equal a squared minus b squared, which is 16 minus 4. So that means c squared is equal to the square root of 12. Now this is where we may have to deal with simplifying stuff, simplifying these square roots. Now remember 12 is 4 times 3, so that means this should really be written as 2 root 3 when we go to find this. So vertices. Now since the y is our major axis, that means that the a values are going to fall on the y value, in the y coordinate of this thing. So vertices come from the a, and this is going to be 0 plus or minus 4. Our focus points always fall on the major axis as well. So these are going to be 0 plus or minus c. And our c was 2 root 3, so this is going to be 0 plus or minus 2 root 3. And then our minor intercepts, that's going to be where we intercept the x-axis, that comes from b. So that's going to be plus or minus 2, 0. Then we can plot these points and make a nice little sketch. It's easier for here to have the major and minor intercepts and then approximate that point in the middle. But we would end up with something that looks like that one. All right, one more time. Let's see what happens. So just like last one, we need to divide this thing by 144. So 16 divided by 144 is going to give me a 9th. So this is going to be x squared over 9. And then y squared is going to be over 16. But let's double check it. Always double check your numbers. Over 16, and that'll make that equal to 1. So we divided it by 144. So this is our b squared, and this is our a squared, because 16 is bigger. So that means the major axis, oh, we're going to find the lengths here, but let's list this so we know this as we go through. I apologize, I didn't read the question before we start. So that means that our major axis is going to be the y-axis this time. That's important because that tells me where my a and my c will fall. They'll be y values this time. So let's see, a squared is 16, so that means that a is 4, b squared is 9, so that means b is 3. C squared is going to be 16 minus 9. So that is the square root of 7. 7's prime, so nothing happens. Sorry. So C is the square root of 7. So I want to find the focus with this. Focus comes from the C, but I'm going to list all of these things. Vertices come from the A value, and since our major is the Y, that's going to be 0 plus or minus 4. Our foci points are also going to be Y's, and those are going to be 0 plus or minus the square root of 7. And our minor intercepts are going to be plus or minus 3, 0. So let's sketch this out the best that I can. So we need a longer y. So this is going to be, let me get an actual tool to make this do this the right way. It's going to look something like that. Get a little bit trimmed around our axis. That's pretty close. Let's put some labels on here. So this up here is going to be 0, 4. This is going to be 0, negative 4. This is going to be 3, 0. This is going to be negative 3, 0. And this first part, we wanted the focus. That is right here. Now, I'm not going to label those on my picture because I'm going to use this to talk about the length of the major and the minor axis. So I'm going to highlight my major axis in yellow. I want that length. Minor axis, I'm going to highlight in green. It's really not too bad because we know this is centered around 0, 0 here in the middle. But this is going to be 4. This length is 4. So the major axis has length of 8. The minor axis is going to have 3 and 3 on either side. That's going to have a length of 6. So that's it. That's all there is to that one. Let's try one more before we sign off for today. Something a little bit different. So find the equation of an ellipse with vertices at 4, 4, negative 4, and focus at 2, negative 2. So let's sketch this out. So since these values are x's, the other ones are zeros, we know that this is going to have a major axis on the x. So let me draw this out first, make it a little bit easier to see. So there's our y-axis. There's our x. And let's put our ellipse in here. And what we know about this ellipse is it has a major axis on the x. Get a little bit more short up. That's a little bit better. So let's label our points. Now we don't know the minors yet, but we know that these major intersect points are at 4, 0, and negative 4, 0. We know the focus points in here. I'm not going to label them on the picture. Let's think about what we need to write the equation now. X squared, y squared equals 1. Now, because this has a major axis on the x, we know that this is going to be A and this is going to be B. We know that this value right here is the A value. So we know that A equals 4. So that means that A squared is going to be 16. So we go and actually start writing our answer in. We know this is x squared over 16 plus y squared. We don't know b yet, because b is going to be these things up here. But luckily, we actually know how to find these, because we know that c squared equals a squared minus b squared. And we know an A, and this right here tells us the C value that we need. So if C is equal to 2, that means that C squared is 4. So that means, let's go ahead and put all of these things in here. So this is 4 equals 16 minus b squared. So we've got a minus this to the other side. We get a negative 12 equals negative b squared. And we get rid of that negative, and it tells us that b squared is equal to 12. Now this is actually what we need to fill in this answer right here. Now we've found its equation. So that's all there is. So tomorrow we'll talk about dealing with them in standard form like I did with parabolas. So just let me know if you need any help.